Okie doke. So what happens when we have two inputs? The one is clean and dirty, sorry, cheap and dirty, and the other is clean and expensive. In this case, as y increases, the increasing importance of pollution damages doesn't just lead to pollution abatement with technology 1, so that's like, you can imagine, yeah, it's like efficiency increases and so on. If we try and think about the structure of the economy, which is very similar to our workforce structure, it also narrows the gap between the social costs of D1, cheap and dirty, and D2, expensive but cleaner. At some points, those social costs are equal, and at that point we start transitioning to the cleaner technology. The transition is gradual because as the transition goes on, emissions decrease, which means that the marginal damages decrease as long as phi is greater than 1. Okay, so it's basically pretty straightforward, and we don't have so many, we can have results for the extremes, right? We know we can find the point at which we start transitioning, and we know that in the very long run, when ALL goes to infinity, we'll only use the cleaner, we'll only use D2. And we can simulate it, which I think is probably the next slide. Yeah, it is. So here, this is Y, this is, which would also be pollution under laissez-faire. This is pollution with including the dotted line if we only had D1. This is pollution if we also have D2. That sorry, I've got to pause here. I think I might have said something misleading before. Yeah, I did say something misleading, didn't I? So if we're transitioning to another dirty input, that transition period won't be spread out over infinite time. It will have a definite starting time and a definite finishing time, at which point we're only using the somewhat cleaner input. And once we've finished that transition, then we're back onto a similar path to the old path, but at a lower level. And if growth keeps going, and if we've still got this unit elasticity and so on, we will actually, in the long run, start approaching the same emissions level as we had before. But if there's a third input that is perfectly clean, then we have a transition to the perfectly clean one, which is goes asymptotically over infinite time. Okay, and here are some graphs which you can, from the paper, you can look at these in the paper. I'm not going to take you through those. So I think that's it for the model, and then we'll just take an intuitive, like an empirical example, and talk you through how that matches to the model, and then we'll talk in more general terms. So I guess it'll be 2 more videos.